Take a look at number 14 in section 5.8, where we're going to evaluate the following indefinite integral. Looks pretty crazy right here. How could we solve for this integral? Can't just look at it and think of an antiderivative. Well, notice I am dividing by e to the x, a sum of, in this case, 3 exponential expressions. So I can just simplify, right? Notice dividing by e to the x is the same as multiplying by 1 over e to the x. So I can just use the distributive property, right? So I'm going to divide each of these by e to the x. And then they simplify quite nicely, right? Here we subtract the exponents to simplify. 15x minus x is 14x. Obviously, this ratio is equal to 1 for all values of x. And then this ratio subtracting, we get e to the negative 9x. Now we can actually find the antiderivative. So look at e to the 14x. What's the antiderivative? Well, it's a little u substitution. If I let u be equal to 14x, then du is just what? 14 dx, right? The derivative is 14. And so 1/14 du is dx. And this integral we evaluate as 1/14 e to the u, where u is 14x. Just double check, right? If I take the derivative of this function by the chain rule, right, e to the 14x would be 14 e to the 14x. And so I need this 1/14 here to make that a 1. The antiderivative of 1 is just x. And similar to what we did over here, the antiderivative of e to the negative 9x is negative 1/9 e to the negative 9x. So I can just plus a negative here, minus, right, that. And here is my antiderivative. I hope this makes sense.